Okay, good day, great hope. Okay, so today we are looking at quadratic functions. Okay, we are looking at quadratic functions. And what you see there is that we're going to look on the transformations, okay, transformation of your graphs. And then after that, you're going to also we'll be talking of domain and range throughout. Then also we're going to look on how do you get the turning point, what is actually the turning point, then also how you get the axis of symmetry, and what you need to consider when you're sketching your graph, okay? Then lastly, we'll be looking at the finding of your equation, okay? So given the coordinates, how do you actually get the equation of the line, okay? Of the equation, sorry, of the function. Now, so it's called quadratic function or parabola because it actually gives you a parabolic shape. Okay, so let's see what's actually happening here. Now, when you check nicely here, remember we have got this x and y. Don't forget, in case whenever you are sketching, you mustn't forget the axis. Okay, so you must indicate that that's your x and that's your y. Okay, then from there you need also to indicate the origin. Okay, so basically when talking of a quadratic equation, all what we know is that it's in the form of ax squared plus bx plus c. But what we're going to deal with when you're dealing with functions here, you're going to start with how are we going to have this, okay? This one is actually like the final one. But now we want to know how it was transformed to actually to come up with something like this, okay? So generally, when you're talking of quadratic equation, they're in the form of y is equals to x squared. Y is equals to x squared. Now, so what we have there is that graph like that, okay? This is f of x is equal to x squared, okay? So that's the graph there, okay? Now there are different transforms that we're going to start with, okay? For the first one, we wanna know what is the effect of, let's say, if we say a f of x, what is the effect of this, okay? So when you look at a, by putting a there, what a does is just, widens or what call our shrinks our narrows our graph. So here we are saying your a there, so like when we have got f of x equals to x squared, like the one that we have there, then if we have got f of x, okay, equal to 3x squared, okay, what do we see? And also if we've got f of x as a fraction, what also do we see? Okay, let's say it's maybe 1/2 x squared. Then another thing again that you need to understand there is it also affects the shape. So your a narrows, okay, or widens graph. So in this case, let's start with this, the effect of what called a in terms of the size of a, okay? So if we are to see this one, it actually what called narrows it, okay? It narrows it, okay? Then if it is half, if it's a fraction, it widens your graph. So we expect to see something like this, okay? We expect to see something like this that is narrow. And if you remember very well from from your this one, f of x is equal to 3x squared, okay? From your linear functions, okay, from functions or one, you understand that when this actually affects, it was in terms of gradient that side, we're talking of steepness, and it's more or less the same in this case as well, where you see that the a does affect, it just shrinks your what you call your graph or widens it, okay? So that's what you actually basically have, but you don't need to worry much about the size here, because you need to worry only maybe if you are to draw these together, or to draw what you call quadratic equations, what you call different functions on the same graph. That's where you need to actually to be wise there and say, all right, you know what, when my a is half, is bigger than, is actually above 0, it means that, oh, it's supposed to be like that, okay? Then whenever it's a, maybe it's a fraction, okay? It's fraction, sorry, it's below 1, it means that it needs to be wide, okay? It widens. Now, the other effect there is the sign of A, okay? The sign of A, sign of A. Now, this is the major thing that you need to understand only. You need to master this only. They're only in case you are drawing them together, you are sketching them together. But here, what you need to worry much about is the sign, okay? Whether it's positive or negative, whether it's positive or negative. This actually matters most, okay? So we want to know what is it, what are we talking about here? So if your graph, if A is greater than 0, okay, and A is less than 0, what you need to know that the shape, general shape, when A is greater than 0, is actually smiling. Okay, it's give you a smiling, and what it does, it have a minimum turning point, and this one here will give you a sad. So this one is actually sad. This one is smiling. Okay, I hope you guys are smiling there. Now smile. Okay, now that's what we have there. And what does it give us? It gives us a maximum. Give us a maximum value. That's what we have there. So it gives us a maximum turning point, okay, when A is less than 0. So you must know always that when A is less than 0, when A is a negative, what happens? Your graph faces down. When A is positive, your graph faces up. That's it. That's what you need to remember there. So you need to consider what you call the sign whenever you're dealing with what you call quadratic functions, and also that will help you also in sketching, okay? Now let's see what's next here. Oh, let's talk of the domain here. Domain in this case here. So let's talk of the domain in the case that, what is it? Our A is above 0. Okay. So let's give an example here. Let's say we have a graph here. I'm just going to sketch here. Okay. So this is smiling. Okay. This is smiling. And we are saying, what is our domain there? What is our domain? And understand something here. Domain, we said these are x values. Okay, so if these are x values, oh, can you see something here? It's actually your graph goes up to infinity in terms of the positive x, and also in terms of negative x, it also goes up to infinity, negative infinity. So basically what we have here, when you're writing our domain, we just write negative infinity or up to positive infinity. Now we can also write this in this way to say x is element of real numbers, okay? Is element of real numbers. So when I think of element of x, element of number, it satisfy all the what call, it can actually have any value. It can only have any value, the x, without affecting the function. So x in this case, x is actually it's not a problem in this case. But now, what about y? What about y? Why we see that our y values here, you can see that the graph will never go this side. Okay, so this tends to be the minimum. So if it is the minimum, in this case, the range we'll actually explain more later when we are going to understand. In this case here, the range, we're going to say, all right, range is actually the y is going to be only above. So for every input of x that we put, we're going to get a y that is above 0. So it's going to be y greater than 0. That's what we have there. So that's what we have in the range, because your graph doesn't go down, doesn't face down. So whatever input of x value that you input, you won't get any negative y. So our y values are actually on top. So it's from your domain, your range is y greater than 0, like that. Okay. All right. Now remember this, where we have in this form, if your equation is in this form, f of x equals ax squared plus q. All right. We know already that what does A does? Your A shrink the graph, widen the graph. Okay, your sign of A determines whether your graph is smiling or it's actually sad. So we are done with the A there. So we are now looking at the Q. We say, oh, what is the Q doing there? The Q, what does with the Q? Q, it causes a vertical, okay, vertical shift. Vertical shift. Vertical shift along Y axis. So this is actually up and down, up and down. Okay, so it's up and down, up and down, up and down. That's what it does with what called the Q. So the Q, you must always remember that the Q actually have a vertical effect, a vertical shift on your graph. That's what you just need to remember there. Your Q there, in other words, is actually the y-intercept. Okay, it's actually the y-intercept. And if you remember very well from the linear functions, we say y is equals to mx plus c, where your c is actually your y-intercept, and in that case, it's actually shifting in the vertical, in the horizontal, in the vertical, sorry. Now, let's give an example here, okay? Let's have two equations here, okay? So let's have two equations here to say y equal to the general equation, y is equals to, what is it? Maybe let's say 2x squared, okay? Then that's the first one. Then the second one here, we have maybe let's say y is equals to 2x squared plus 9, okay? Then the other one is y is equal to 2x squared minus 3, okay? Then the fourth one there, let's just say y is equal to negative 2x squared, actually plus, minus 4. Okay, now let's start with the first one here. Okay, we're going to know that, oh, that one is passes through the y. And in this case here, understand something, your graph still lying in the y-axis. The turning point is still in the y-axis. Okay, that's where it is turning. Okay, now let's see what we're going to have here. So this one is y equal to 2x squared. That's what we have there. Okay, now what about 2x squared plus 9? Oh, we know that we shifted this graph 2x squared 9 units up. So we expected to see that turning at 9. So we put 9 there. Then we shifted our graph. That's what it means. We shifted our graph 9 units up. That's what we did there. And let's look at the third one. Third one is saying 2x. So this one is 2x squared plus 9. Okay. Now the third one here, saying 2x squared minus 3. Oh, this one, we're moving it 3 units downwards. Okay, so we're going to put minus 3 there. Okay, then we put it there. Then say, all right, let's put it like that. Okay, that's what we have here. Remember, these are just general sketches. Okay, y is equals to 2x squared minus 3. Okay, so we moved negative 3 units downwards. Okay, according to what we have. That's our Q there. Now, the third one, they say minus. Oh, can you see something here? Minus. So if it is minus, it mustn't face up. It must face down. That's what we remember. But now we told that it's shifted negative 4 units. So we expect to see it at negative 4 there. And what we have there, because it's facing down, it will go down like that. That's what we have. So that's actually basically what we'll end up having there in this case. So that's the effect of Q. So effect of Q is vertical shift. Vertical shift, always remember that, okay? Oh, now, what's happening now? So here, let's see what we have here. Let's see what we need to worry about here first. Look here, we spoke about the A. We are done with the A, okay? Now, let's see the Q. We spoke about the Q. We are done with Q because Q, we know that is causing a vertical shift. A, the sign will determine whether it's smiling or it's sad, okay? Now, the P is a new thing here. So let's check here. What are we going to do with the Q? What about the P? What does the P does? The P is actually give a horizontal horizontal shift. So in x-axis. So now listen carefully here. We have been going up. Okay, now what are we going to do now? We are going horizontal. We are going horizontal. Okay, that's a horizontal shift. So P does the dancing. Okay, does the dancing there is actually horizontal shift, and that's what you need to remember there. So the horizontal shift by P units. Okay, so now let's have an example here. Okay, we just wanna keep up with whatever we're having there at first. So let's just say what is it? F of x. We say f of x is equals to, let's say, 2p. So 2x squared. Okay, 2x squared. We saw that, and f of x is equals to 2x squared plus 9. Okay, now let's have another one. F of x is equals to 2 in brackets x minus 4 plus 9. Okay, now let's see what's going to happen there. And after that, we will also want to draw, what is it, another equation there of f of x is equal to 2x plus 4 plus 9. Okay, that's what we want. And also the last one, we would want also to do minus 2x plus what is it, plus 5 plus 9, and just want to see what's going to happen. Okay, so let's see what's going to happen here. I'm not going to use a ruler here, guys. Now what we have here, let's have a drawing, a sketch here. Okay, a sketch here. Remember, when you're sketching, it's very much important to put the y and the x and the origin. Okay, now let's see what's going to happen now. Now here we know that 2x squared, where is 2x squared? I'm going to put it in dots here. Okay, that's a 2x squared, the first one. Okay, 2x squared. Okay, now what about 2x squared plus 9? Oh, 2x squared plus 9, what do we have here? Okay, now what about that one now? We have this plus 9, but not. Let's do something here quickly. Let's not have this one first. Let's check also the first one. Let's just check a simpler one of f of x equal to 2, okay, x minus 4, just like that. X minus 4, just like that. So that we have an understanding what's going on here. Okay, so what we're going to do here, we're going to say, all right, when you have 2x squared minus 4, 2x, then we put a square there, x squared like that. Now we know that, all right, this is our original graph here. What must we do? We must move 4 units. Where must we use 4? We must move 4 units where? Because remember, we want to come back to our transformed, what call the transformed, equation here. And how do we do that to get to that? Because we're going to say, if it is to come to our original here, we're going to say, all right, 2x minus 4 plus 4. So we need to move these 4 units. We need to move the whole thing here 4 units to the right. We need to move plus 4 so that we be left here. If we say minus 4 plus 4, we'll get 2. We'll get a 0 here, so you'll get actually 2x squared, which is what we have here on top, which is our original graph that we're dealing with here. So we need to move 4 units, okay? 4 units, so it's gonna be 4 units to the right, okay? 4 units to the right. So that's what we have here. So this one is 2x minus 4 squared. Okay, that's what we have. That's the graph there. So now here's the trick that you need to master here. When it's minus minus whatever units that we have, minus 4 units, you need to move to the right. You're opposing here. When it's plus 4 units, you need to move to the left, because we are trying to go back to whatever we had before, okay, to our original equation there, to cancel everything there. Now, so let's come back to this one. We are going to shift this 4 units, this graph here, 4 units up. So it's going to be like this. So this one is going to be at 4, is 9 and 4. And what is going to be, is going to be, what is it? 2, going to be 2. This is actually the graph. 2x minus 4 plus 9. Okay, that's what we have there. That's what we'll get. Okay, that's what you need to remember there, to say when you are moving to the left, instead of when it's plus, like in this case is plus 4, for us to get the original here, to cancel this 4, we need to subtract. So how do we subtract? We subtract by 4 units. So we're actually moving to the left 4 units. So in this case here, the graph of that one will be somewhere here, where it's gonna be hanging here. Okay, this one will be the graph of 2x plus 4 plus 9. Okay, that's what you'll be having there. So that's what you will be having there. So that's what you need to just master there, and say whenever it's plus here, when it's plus inside, you move to the negative. When it's minus, you move to the right by those given units. Okay, so just remember that whenever you have plus, move left, negative, move right. Okay, so that's it. That's what you just need to remember. So that's what you need to remember there, to say when it's plus, we are moving to the left. When it's minus, I'm moving to the right. Okay, so let's see what's next there. Now, let's talk of the turning point, and we understand that the turning point is either the max, either it's a max minimum like this, or a maximum, which depending on the shape of the graph. Now, here the turning point, you must understand something here. Turning point, by the turning point, we already understand that we are having Q, because Q determines where your graph is, like your where it's touching, where it's actually it's intercept. Okay, so it's actually determining how far we have shifted the graph. Okay, so in that case, that's Q. So Q already is there, you know it. Okay, then now if you are left with what called with Q, it means that you know that a turning point, okay, y value is equals to Q. Okay, now what are you left with now? What are you left with now? Listen now, when the what was the x value there? The x value, oh, what will be the x value here? Let's see what's going to happen now. The x value, if we are left with, if we take out this, what is it? We have, what is it? We are saying a turning point, the y value is Q, okay, because you know that, okay. Now, what about what about the x value? The x value is your negative p. The x value is negative p, because what are you going to do? You're going to say, all right, a turning point, the x value here, where it's going to touch, it's going to be, what is it? Let's see, what is it here? It's going to be a x plus p squared equal to 0. Now, in this case here, what are we going to do here? We divide everything by 0 there, and we'll be just left with x plus p is equal to 0. Then x is going to give you negative p. So at every turning point, therefore, you get it by saying negative P Q. That's it. Turning point. Negative P Q. That's it. That's your turning point. Now, want to understand, oh, why are we saying that? Now, let's have an example here. Let's have an example here of whatever we are having here. Okay, let's have an example of whatever we're having here. What do we have here? We have got, what is it? We have got 4, okay, 2 and 4. Okay, can you see this? No, I can't. Now, let's just see here. Okay, let's have that's equation that what we're having here. Okay, let's have an equation there of f of x is equal to 2x minus 4 plus 9. Okay, and what did we say? What is our p there? Our p is 4. Okay, our p is negative 4. Sorry, our p is negative 4, and our q is 9. So what did we say here? TP is equals to negative p q. That's the coordinates, which is going to be negative of negative 4, 9, which is going to give us what? Negative times negative is going to give us, is going to be 4 and 9. That's the turning point. So that's the turning point. And if we check here, if we check what we have here, what we have here, the graph of, what is it? The graph of 2x minus 4, you can see that the turning point here is where we have got 4 and 9. That's the turning point. So simple like that. So you don't need to stress much here about the turning point of of your quadratic equation in this form. You mustn't worry much, because just know that, all right, whatever value that I'm having there, I'm just gonna say negative P Q. That's my turning point. That's the turning point. You don't need to stress. So for example, again here, if we have got what is it? Even if it's given as y is equal to negative 2x plus 5 plus 9, okay? Sorry, not seeing anything here. Now, y is equals minus 2, yeah, like that. Even if it's like that, you don't need to worry here. You just know that whatever I'm going to get, the negative is only going to show you, is it going to be a maximum or is it going to be a minimum? So in this case, if it is a negative, it shows you that it's going to have a maximum value. Now, so what we have here is going to be x turning point is equals to negative P Q. And what is P there? P is 5, is going to be equals to negative 5 and 9. Okay, that's the turning point there. Simple as that. But now, it's not always like that. It's not always like that, okay? Sometimes we are given a quadratic equation as maybe, let's say, f of x, when the quadratic equation is in the form of a, so we're still on turning point. In the graph, we need to quadratic equation in the form of ax squared plus bx plus c, okay? Your turning point, x value, TP is going to be equal to, x is going to be equal to minus b over 2a. So you need to find the x value. Then by finding the x value first, you substitute into the what you call into your equation like that. You substitute into the equation like that, and you see actually what's happening there. Okay. Okay. Just a recap there. I've seen that I forgot to put the 2 there. So previously we were doing without the 2 there, and we must supposed to put the 2 this for the square there. Okay. But I hope you guys understand. Now, let's have an example there of, so that you can understand, have a better understanding of what's actually going on. Okay, to make it easy for you and also for you to understand, what I've done there or done here is that I expanded the previous question that we just did now. Okay, so that you can see if we're going to find the same what will turning point. Okay, so in other words, you might get the equation like this. Okay, and in this case here, you need to actually to come up with this, you need to do what you call complete the square, but here it's unnecessary. So now let's see what you're supposed to do here. We said x value is, you find x value by saying minus b over 2a. So what you need to do first is saying a is equal to 2, okay? A is the coefficient of x squared, then our b is equal to negative 16, okay? That's all what we want in this case, okay? So what are you going to do now? We're going to say the x value at a turning point, at TP, okay, x is equal to minus b over 2a. So what is minus b over 2a in this case is supposed to be negative 16 over 2. What is the a? Is 2, like that. Then it will give us what? It will give us negative and then negative. It's going to give us positive. It's going to be 16 over 4. And in that case, 4 into 16 is going to give you get what called 4. Okay, that's what we have. So the x value, we have it now. Then we substitute x value, x equals to 4 into original equation. Okay, that's what we do. That's what we do now. So now what you're going to do, you're going to say your y value is going to be equals to 2. Okay, we have got 4 squared, okay, minus 16, 4 plus 41, and we see what we get there. So let's get to see here what's happening here. We're saying 2, and we say 4 squared minus 16, okay, 4 plus 41. What do we get? We get 9, okay? That's our 9 there. So in other words, the turning point there, the TP is equal to, what is it? 4 and 9. And if you remember very well, that's what we have here, 4 and 9. Okay, so if you have to compare there, that's what we have here, 4 and 9 here. So that's your turning point. So that's how we're supposed to find it. So make sure that you master these methods to see if I'm given it in this form. I don't need to worry. You don't need to worry. Pick whatever you have, minus PQ. That's it. Irrespective of where the graph is facing, it doesn't matter. Okay. Then here, if you are given an equation in this form here, in this form, oh, what am I supposed to do? I need to find x value first, then I substitute in the original equation, then I come up with the answer. Okay. So let's see the next one. The next one, we're going to look on the axis of symmetry. Now, axis of symmetry here, okay, my handwriting is not that good. Now, axis of symmetry is actually passed through the the turning point. So axis of symmetry here is actually passed through the the turning point. Like in this case here, let's have equation of axis of symmetry. That's what normally comes. Okay, let me just show you here. Okay, so by finding the turning point, you know the x value. So in other words, the equation of the turning point, you just say x is equal to what? X goes to minus b over 2a, and whatever you get here, this is the equation of of a turning point. Like in this case here, the axis of symmetry, equation of axis of symmetry is x equal to 4, because at x goes to 4, that's the line that divides your equation into mirror images. Now for this one here, it's passed through 0. Okay, it's passed through the origin. So what happens at the turning point is that x equal to 0. So x is equal to 0 is actually equation of the turning point. That's what you need to remember there. Equation of the turning point, don't need to stress much. Pick the x value, and in other words, when it's in this form, to say maybe it's f of x equal to a x plus p squared plus q. X of symmetry, equation of axis of symmetry, what you need to get there is just a x is equals to negative p. That's it. That's the equation of axis of symmetry. So just find the p there. The p is given already, so it's actually equal to negative p. That's equation of axis of symmetry. That's simple as that. Okay, so we don't need to stress much here. Once you find the turning point, that's where you find the x of symmetry. X of symmetry is x value only. Okay, so don't stress much there. Okay, now we are going to look on sketching, and when you are sketching, firstly, check the sign of A. So it will determine whether the graph is gonna be sad or smiling, like I said before. Then the turning point, how do you find the turning point? You use this method like minus PQ, or you use where you are saying the Y value is, the X value is minus B over 2A, and the Y value will be a substitute of that. So f of minus b over 2a. That's what you are saying here. Then remember, it's very much important when you're sketching a graph. It's a sketch, nothing is done to scale here, but you need to indicate where the graph cuts the x-axis. So it's very important to check if it cuts the y-axis, indicate the y-axis where it cuts the y-axis, and if it cuts the x-axis, it's always good to show. Okay, but in most cases, in all cases, it has to cut the y-axis, but in some cases it doesn't cut the x-axis. We'll talk about that and understand. All right, let me just show you here where it doesn't cut the x-axis. Let's say a is less than 0. Okay, let's say it's just like what is it? It's like what is it? Graph of y is equals to what is it, x squared, okay, minus x squared minus 3. Okay, what we have there is a graph there. We move minus 3 units down, and it's facing down, so it will never touch the x-axis. So in this case, there won't be values for x-axis. That's why you see sometimes if you remember well, in nature of roots in the algebra, we said in some cases there are no real roots. In this case, this is what we'll be talking about, okay, because the graph won't be touching the x-axis. It's actually shifted like that, and it doesn't have to go down there, so to never touch the axis. And we are saying there won't be roots there, meaning there won't be x values. Okay, then from there you will need to indicate what in that case, what is the domain in that case. Okay, in whatever you're given there, what is the domain and what is the range. And understand something there, the domain is always x element of real numbers unless if it is restricted. Okay, because we know that x is, like I said before, x is going to go wherever it wants. But the range now, when it's maximum, you know that what is it? When is the maximum turning point? You know that you're going to use what called q. But then I'll show you what I mean by this, because now I think I'm talking too much. Now, y is equal to 3x plus what we have here, and we know that generally our shape is going to be smiling. Okay, now what is our turning point there? The turning point, we know that TP, okay, so TP is going to be equal to what? Minus P, okay, and Q. And what is minus P and Q there? It's going to be minus of minus 5, okay, and 6. That's what we have there, which is going to be 5 and 6. That's the turning point. So we got the turning point. Okay. Now, what is the y-intercept? Y-intercept. Where does this touch the what called the y-intercept? Now we need to think now. Right. Where is it going to be touching the y-intercept? Okay. When x is equal to 0. Okay. When x equals to 0, what's happening? So y-intercept, we know that very well. So we're going to say, all right, y-intercept, y-intercept, x is equal to 0. Then you're going to say y is equal to 3, 0 minus 5 squared plus 6. And what do we get there? We get what? We get, what is it? 3 in brackets minus 5, okay, squared, okay, plus 6. What do we get? We get 81. So that's 81 for us then in terms of y. Then the x-intercept, okay, it's when y is equal to 0. And when y equal to 0, what do we do now? We're going to say, all right, we have our equation there is 3, okay, is 3 x minus 5 squared plus 6 is equal to also 0. Okay, what do? We take 6 that side, okay, gonna be 3. We don't need it, there's no need for you to expand here, remember, because if you remember what you call completing the square, you reach this point, what you need to do, you take the x, this value there, then you divide, then you find the root of that, okay? So you're going to say x minus 5 is equals to negative 6, and x squared, sorry, x minus 5 squared is equal to negative 6 divided by 3, which is going to be negative 2, okay? So here, what's going to happen now is that a root of that, because to find x minus 5, we're going to say it's going to be plus or minus root of negative 2. And in this case here, there is actually, it's not real. So this not real. So no roots. So in this case, this graph doesn't pass through the x, it doesn't cross the x-axis. So you know that you are sharp there. So you don't need to worry about the x-axis, okay? So what else you need to know there is that what called the domain here. The domain, actually the domain is, you actually be clear when you sketch it, okay? When you sketch it. Because remember your domain, you don't sketch the domain, but you explain the domain, okay? State it to say what is my domain there. So that's your x, that's your y. Now, what are we talking about here? Let's see here. We are told that is suppose the turning point there. We're told that the turning point, this is our 0, and the turning point is told that it's 5 and 6. 5 and 6. So let's just talk of maybe 5 in this. Let's say it's 5 is here, okay, and 6 is somewhere here, okay. So where these two meet, it's actually here. That's our turning point, okay? Then what is it? What is our y value? Our y value is 81, okay? But now, can you do something here so that it's going to be practical? Let's put our turning point here, okay? It doesn't matter. Let's put our turning point here, which is 5 and 6, okay? Let's say here is 5, here is 6 units, okay? Then we're told that the turning point there, it crosses at 81, that's the y value. So y-intercept here is 81. So let's put 81 there, okay? Now, what are we going to do now? We know that our graph here is turns here and is facing up. So that's the turning point. So we started from the turning point there. It's supposed to touch the y-axis at 81, and it goes up like that, okay? Then we know we are done. We are done with our sketch. We're done with our sketch. And what we need to do here, you label f of x is equals to what? Is equals to 3x minus 5 squared plus 6. That's what you need to remember. That's what you need to remember there. That's our equation there. That's how you label. Now, the domain, what is the domain? Remember, domain x element of real numbers, okay? Or negative infinity to positive infinity. That's what you need to understand. So that's your x values, that's a domain. What about the range? Now the range, for quadratic functions, you know that, all right, here is gonna be from its y greater than 6, because y is gonna be y greater than 6. So okay, so y is gonna be greater than 6. That's what you need to remember there. Y is gonna be greater than 6 because it's starting from 6 going up. So whatever input of x value that you put here, we're going to get a value that is above 6. So it's going to be 6 greater than 6. That's our range. So now, when your graph have a minimum for when you have put f of x equal to what? Equal to what is it? To a x plus p plus q, okay? In that case, now domain x is always element of real numbers. You mustn't worry there. As long as it's a quadratic function, x is actually element of what called real numbers. Then range, okay? Range for maximum, when it's maximum, so when a is above 0, okay, it's greater than 0. So when a is above 0, it's a minimum, it does have a minimum. So it does have a minimum here. So minimum TP. So for minimum TP, you know that how do you get the range? Range is gonna be like in this case here, range is just have to be y greater than q. That's it. Now, what about for maximum? So when maximum TP, when a is less than 0, okay, when a is equal to less than 0, what is our range? Our range, so in this case, your graph will be like that, okay? So our range there is just y less than p, less than q, sorry, less than q. That's what you need to remember there. That's it. That's it for what is it for the sketch and the what called and the turning point. So just understand something there, that if an equation comes in the what called in the equation in the form of ax squared plus b squared plus c, just know that you need to find the turning point using the formula of minus b over 2a. Then once you get the turning point, the rest you still do what you call what you're supposed to do. Okay, then here you know the domain, you know the range, how do you get it? Okay. Okay, now you are given this type of equation, you're given an equation. Remember something now. When you're given this question, it's not gonna be coming like this, okay? It's easy as this, okay? Yes, it will be easy like this, but the thing is, they just mix up with other type of what called other type of graphs, and just to blow your mind. But now you don't need to worry much. Now, when they ask you to find the equation for quadratic function, okay, you mustn't stress, okay? You use when you are given the what you call when you're given the coordinates, okay, you use the general formula here. Use the general formula, okay, which is y is equals to a x minus x1 x minus x2. That's it. So your x1 and x2 are your coordinates, are your roots. So x1 and x2, x1 and x2 are the roots. So these are the roots, these are the x-intercept, these are the x-intercept or x-intercept. Okay, that's what we have here. Those are the x-intercept. In this case here, it's -1. Okay, so for x1 there, in this case, x1 in this graph here is going to be equal to -1, and x2 is going to be equal to 4. That's what we have there. So x is either equal to -1 or equal to 4. And now we want to calculate, we want to find the equation. Okay, so what must you do? Use the formula that we have here. So let's see what we're going to do now. We're going to say, all right, it's going to be a x minus 1, okay, in bracket x minus 4, okay. Then what do we get there? We get a x plus 1 x minus 4, okay. Then let's multiply this, a x times x squared, Now what do we have here? X squared, x times -4 is -4x. We're done there. 1 times x and b plus x. 1 times -4 minus 4 is equal to what? Is equal to y. Now, what's left there? You're going to say a. Let's put a inside there. So, okay, let's put a inside a x squared minus 4 plus x is going to give us plus minus 3x a minus 3ax, sorry, then minus 4a. Okay, that's what we have there. So that's what we have, and that's what you can see there. Now let's see what we're going to do now. Okay, now you have your general equation here in this case here, and you know very well the general equation. General equation is a x squared plus bx plus c. Now, what you need to know there, you know that c is the y-intercept. So c is the y-intercept. And in this case here, what is the y-intercept? Y-intercept is 2. y-intercept is 2. So, and the y-intercept in this case is what? It's negative 4. So you need to know that, all right, how do you get the value of a? You're going to say the negative 4, okay, finding a, okay, finding a, you're going to say negative 4a is equal to 2, because negative 4a is, in this case here, is your c, and that's your y, and that's where it cuts the what called, is cut the y-axis. Now, how do you get the a? Is going to be equal to what? A is going to be equal to what is it? 2 over 4, 2 over negative 4, which is going to give us negative 1 over 2. That's what we get there. That's our a. So our a becomes a negative 1 over 2, okay? Okay. Now, after that, what do you do? After that, what you do, you substitute a equal to negative 1 over 2 into y is equals to a x squared minus 3ax minus 4a. Then you find the equation, which is going to be y is going to be equal to negative 1 over 2 x squared minus 3 in brackets negative 1 over 2 x minus 4 negative 1 over 2. Okay, that's what we have there. Now you calculate there, you get y is equals to minus 1 over 2 x squared minus minus going to give us positive, so it's going to be plus 3 over 2 x minus minus going to give us also positive, it's going to be plus 2, because 2 into 4 is 2. Okay, that's what we have. So we end up having an equation like that, 3 over 2, sorry, here. Then if you want, you can multiply throughout by 2 to remove what you call the fraction there, times 2 times 2 times 2 times 2 is going to give us 2y is going to be equals to negative x squared, okay, negative x squared plus what? What is it? But no, it's fine. You can leave it like this. Just leave it. You can leave it like this. Don't want to complicate it. You can just leave it as y is equal to negative x squared, okay, plus 3 over 2x plus 2. That's your equation there. And you can see it does make sense here. You can see it does make sense what we have here, okay? It does make sense what we have here, because your graph here, you can see that it's facing down, okay? It's crying here, it's sad, okay? Then it passes through these points, okay? That's what we have there. And another thing that you can also use to make sure that, just to prove that your answer is correct, you can substitute 4 into this equation to see if you can get a 0 in terms of y. Let's do it again. Let's do it together. Minus 1 over 2. We have what? We said 4. Okay, it's fine. 4 squared. Okay. Plus 3 over 2. 4 plus 2, what do we get? We get a 0. So that actually shows also that your equation is right, because when you put 4, you must get a corresponding 0. Okay, so actually, guys, this is actually what is it? This actually is the end for this lesson. Okay, this is actually the end for this lesson, and what we have there is that, you guys, I hope you guys understand. I'm going to do the hyperbolic and also exponential functions separately. I hope you guys enjoyed the lecture. Okay, don't forget to follow us on YouTube, Facebook, Instagram, and Twitter. Okay, and if you have any questions, just try to call us. Okay, so until next time, cheers, bye bye.